All right, let's jump right into this explainer and unlock one of the most incredible, almost mind-bending mathematical secrets ever discovered. If you've ever looked up at the world around you and wondered, how in the world did they figure out the size of things we can't even reach? Well, you are in the exact right place. Today, we're learning the ultimate measurement cheat code.
Seriously, just think about this for a second. How would you actually measure a giant towering pine tree in your neighborhood? I mean, you can't exactly climb all the way to the very top with a floppy tape measure, right? That'd be ridiculous. And what about a mountain? Or let's go even bigger, a star millions of miles away. For a huge chunk of human history, this seems like a totally impossible problem. But the answer to calculating these massive heights and distances, literally without ever leaving the ground, is hiding in a very specific, very familiar shape.
And that secret weapon? It's called trigonometry. Now, okay, I know that is a big, kind of intimidating word, but seriously, don't let it scare you off. If we break it down into its ancient Greek roots, it makes perfect sense. We get trigonon, which simply means three angles, a triangle, and metron, which means measure. And that is literally it. Trigonometry is just the science of measuring triangles. And once you know how to measure a triangle, you can pretty much measure the entire universe. Section 1. The magic of triangle math. Let's look at how this builds from ancient history into the modern tools we use today.
So the story of triangle math starts way back around 2000 BC with the ancient Egyptians and Babylonians. But things really kicked into high gear with a Greek astronomer named Hipparchus of Nicaea around 125 BCE. This guy wanted to track the stars and calculate the exact length of a year. And get this, he actually did it to within 6 minutes. To pull that off, he created these special tables showing the relationships between angles and lines, which totally earned him the title the father of trigonometry. He also helped popularize dividing a circle into 360 degrees, borrowing a base 60 number system from the Babylonians. Fast forward to today, and this exact same ancient math is literally the invisible engine running our entire modern world.
Section 2. Meet the right triangle. This is the specific shape that makes all this math magic happen.
The right-angled triangle is the absolute superstar of trigonometry. You can always spot it by that little square box sitting right there in the corner. That box tells us that one angle is exactly 90 degrees, meaning it goes perfectly straight up and perfectly flat across. And directly across from that right angle, that is always the longest side of the triangle, which we call the hypotenuse. You might actually already know this shape from the Pythagorean theorem. A squared plus b squared equals c squared, which helps us find the length of that hypotenuse. But to really unlock trigonometry, we have to name the other two sides. And honestly, this is where a lot of people get tripped up at first, but actually it's super simple once you just pick one of the other angles to focus on. Imagine you are standing right inside that corner. The side way across the triangle from you, the one you weren't touching at all, that's the opposite side. The side that is physically right next to you, practically touching your feet, is the adjacent side. So just remember, opposite means across, adjacent means right next to. Simple, right?
Section 3. Sine, cosine, and tangent. Here's where we learn the magic spell that ties these sides and angles together.
So there are three main rules or ratios in trigonometry that describe exactly how these sides relate to one another. They're called sine, cosine, and tangent. Now, to remember which rule uses which sides, we use a classic memory trick. Honestly, it sounds like a magic spell or like a cheat code combo in a video game. So, ka toa. So means sine is opposite over hypotenuse. Ka means cosine is adjacent over hypotenuse. And toa means tangent is opposite over adjacent. Take a really close look at tangent. Notice how the tangent of our angle equals the opposite side divided by the adjacent side? This right here is the exact cheat code we need for our giant tree measuring problem. Remember toa. If we know our angle and we know our horizontal distance to the object, which is the adjacent side, we can use tangent to solve for the opposite side. And that opposite side, my friends, is the exact height of our tree. Section 4. How to measure trees. Okay, let's turn this abstract math into a real-world backyard adventure. To find that all-important angle pointing up to the top of our tree, we need to build a scientific surveying tool called a clinometer. And the best part? You can build this awesome gadget right now with stuff just lying around your house. Step 1. Cut a piece of string to about 12 inches. Step 2. Tie or tape it right to the center hole of a standard math protractor. Step 3. Attach a small weight to the bottom of the string. A binder clip works absolutely perfectly for this. And finally, take a regular drinking straw and tape it right along the flat bottom edge of the protractor. And boom, there it is, your finished clinometer. Now, I know it might look like just a protractor with some string and a straw taped to it, but it is actually a highly effective angle measuring gadget. Here's how it works. As you tilt the straw up, gravity keeps the weighted string pointing completely straight down. This allows you to read exactly how many degrees you are tilting the tool just by looking at where the string crosses the protractor scale.
So, let's put this new superpower to use. Go outside, find a towering tree, and walk away from it until you have a clear, easy view of the very top. Stand completely still, hold your new clinometer up to your eye, and look right through the straw like it's a spy telescope. Aim that straw directly at the topmost tip of the tree. Let the string hang down freely, and wherever that string crosses the numbers on the protractor, that right there gives you your angle of elevation.
Now for the grand finale, the magic math. See how you, the perfectly flat ground, and that tall tree form a gigantic right-angled triangle in the real world? All you do is measure your distance from the tree with a regular tape measure. That's your adjacent side. Then you look through your clinometer to get your angle. Finally, you just plug those two numbers into your tangent equation. Remember TOA. Multiply your distance by the tangent of your angle, and wow, you've just calculated the exact total height of that tree, the opposite side, without climbing a single branch.
Section 5, Real-World Trigonometry Uses. Let's see how this builds into massive applications way beyond just the backyard.
You see, when you're doing this, you aren't just messing around with a math worksheet. You are practicing a skill used every single day by professionals. Forestry workers use these exact same principles to track how fast massive forests are growing. Engineers and architects use trigonometry constantly to calculate building heights, the slopes of roofs, and road inclines. Video game designers, they literally couldn't do their jobs without it. They use it to calculate physics, character jump arcs, and totally immersive 3D animations. And astronomers are still using Hipparchus's ancient triangle math today to measure the distance to stars that are light years away from Earth.
As this quote brilliantly sums it up, trigonometry helps us find angles and distances, is used a lot in science, engineering, video games, and more. It really is the invisible structural framework of the modern world. By just understanding how the sides and angles of a simple triangle talk to each other, you gain the absolute superpower to measure the unmeasurable.
So now that you actually know the cheat code and you know exactly how to build the tool, the only question left for us is, what are you going to do with it? Seriously, grab your string, your straw, and your protractor, head outside. What impossibly giant object in your neighborhood are you going to measure first? A telephone pole? Your house? Maybe the tallest oak tree on the block? The entire world is just a bunch of giant triangles waiting to be measured. Go have some fun unlocking them.